At the end of this video lecture, students will be able to calculate the molar mass of a gas using this equation that relates density and molar mass to the ideal gas law. So we can go ahead and look at the relationship between density and molar mass and how they connect directly to the ideal gas law. So we're going to go ahead and look at this equation that we have here really quickly. So the molar mass is equal to the density times our gas constant times our temperature divided by pressure. Okay, we're going to look at how we derive this equation really quickly, and then we are going to apply it. So if we start with the ideal gas law as we have written here, and we start with the equation for density equals mass over volume, and go ahead and solve the density equation for a volume. So volume is going to equal mass over density. Okay, so now that we have solved the density equation for a variable that shows up in the ideal gas law, which is V, we're going to go ahead and plug our new volume in with its corresponding mass and density variable. Okay, so P times M over D is going to equal nRT. Okay, so now that we've had that, we're going to go ahead and manipulate this equation and solve for density by itself. So that's going to give us the equation as so. Okay, and what we have here is pressure times mass divided by moles times our gas constant times our temperature. Now what I want you guys to notice is the fact that we have mass and moles in this equation. So in this context, we know that both of these happen to be related to density and our ideal gas law. So if we have mass over moles, okay, that's going to be equal to our molar mass. Okay, and if we go ahead and plug in our molar mass in the position of the mass divided by moles that we saw up here, we will get the following equation. And now that we have this equation, if we go ahead and solve for our molar mass, okay, we will end up with this equation here that allows us to interrelate density and the ideal gas law to our molar mass of our substance. You guys want to memorize this equation and make sure that you know that our big M here represents molar mass. Okay, and then our D here, of course, represents density. Okay, so the problem here, they've told us that we have a container that has a volume of 2.10 liters and contains a mass of 4.65 grams of a specific gas at a pressure of 1 atm, okay, and a temperature of 27 degrees C, okay, and they want us to calculate the molar mass. So in order to calculate our molar mass, we're going to use the dRT over P equation that we just derived on the last slide. Okay, and then we're going to look at the variables that we need. First and foremost, we're going to need a density. Now, they have not provided density, but they gave us mass and volume, which will allow us to calculate density and plug into this variable here. R, we need R, but that's a constant, so we should know that. That's going to be 0.0821 liters times atm per mole Kelvin. Okay, and then now that we have that constant, we want to make sure that our units associated with this equation match up with our constant. Okay, so our pressure value here matches up with that constant. Our temperature value, however, does not. Okay, so we need to convert that to Kelvin, much like we've done in previous gas law problems. Okay, so we're going to go ahead and do that by adding 273.15. Okay, as so. All right, and now we're going to go ahead and plug in our values. So now that we've plugged in all of our values for all the variables, we're going to go to calculate, and that is going to give us 54.565 as our numerical value. If we go ahead and look at our units, okay, Kelvin and Kelvin are going to cancel. Liters and liters are going to cancel, ATM and ATM are going to cancel, and I have grams per mole being my remaining unit. So grams per mole are what I'm going to have down here. Okay, now in terms of sig figs, we're going to have 3 sig figs in this answer, so 54.6 grams per mole is going to be the molar mass of my gas in this container.